If you don't have it out, go ahead, grab it out. Make sure you're kind of looking at this. Last week, there were a lot of people were missing. So real quick, P of E is one way of notating the idea of the probability of something happening. It's either going to be 0% or 100% or something between. It doesn't make sense if those numbers are not between 0 and 1 or 0% and 100%. It doesn't make sense if it's 1.6. So I'm going to put this up. Is that pretty seeable? Cool. I dig that. Right. So what's the difference between empirical and mathematical? Questions here? Can we keep going? If I flip a coin, I expect it to be heads half the time. That's mathematical. If you flip a coin, it turns out that tails is slightly less likely. So, or more likely rather. So that's empirical. I've observed the evidence empirically. Yeah? Okay, this is the one I wanted to talk about. We talked about rational numbers. Do you remember that conversation? It's not even working. There we go. Like a number divided by another number is a ratio. So any two numbers that are whole numbers being divided by each other makes this thing called a rational number. Decimals are always rational numbers unless they repeat, or unless they don't repeat and go forever. So for example, if we have 0.66666, wow, that's weird. That goes on forever. Since it's repeating, that's still a rational number. That happens to be 6/9 if you put that in your calculator, or 2/3. But if you were to get a number like, for example, 3.141592 blah, blah, blah for infinity ever, that's not a rational number because it doesn't repeat. So that's how you can know. If you're looking at a fraction, it's a rational number if it's expressed as the ratio or two things being divided like this. So that's not an approximation unless, what is 5/9? Anyone know? Yeah, it goes on forever. That bar over the top means just repeats forever. It's 0.5555555 repeated forever. So is this an approximation?
Yes.
Why? And what is the approximation? How did we get that?
556.
Yeah, what happened?
It was rounded.
Yeah, we rounded the last number. Your calculator will do that. So keep that in mind. The more digits you use, the more accuracy you'll have in your calculations. When you're doing statistics, I tend to use as many digits as possible because you'll get these ridiculously large or ridiculously small numbers that can be highly affected by rounding. So there you go. That's that. Probability written as a fraction or a decimal, is this an approximation of that? And the answer is no. If you type 3/4 into a calculator, you'd literally get 0.75. Proof is in the pudding. There you go. Not an approximation. Okay, cool. Do we need to talk about any of these? I'm happy to. It doesn't make you dumb if you want to talk about it. It's cool.
Yeah,
All right. Real quick. So we got 350 tickets for our raffle. 350 for a Yeti ice chest. John buys 5, and now we have to make an assumption. If all the tickets are equally likely to be drawn, assuming they're all equally likely, then we have a 5 out of 350 probability of that happening. I don't want this as a decimal. Please leave it as a fraction in my class, because now I know that you understand exactly how this works. If you want to make it a decimal, fine, type it in your calculator, but I don't need that. If he buys all the tickets, he's gonna win, unless somebody cheated. 100%. Guaranteed. And why can it not be less than 0? Because 0 means you're not going to win. Can you have lower probability than never? Imaginary probability? I don't know. It doesn't make sense. I don't like it. Can it never be greater than 1? Same thing. Fun. Okay, 120 golf balls. Whoa. If the probability that it's pink is 0, how many pink golf balls are likely to be in the box?
0.
None. That's right. If the probability of yellow is 0.25, how many yellow golf balls are, and again, likely to be in the box?
1/4.
Yeah. 1/4 or 0.25 of 120. This pen's slightly broken. So whatever that gives you, is that 30? 30 yellow golf balls. And again, with probability, nothing's for sure, right? Unless we know that we have every single piece of the population, then we can be for sure. Stats is not about gathering all the data. It's about making predictions using data that it's responsibly, fiscally to gather. That was horribly said. Doesn't cost too much. Yeah, costs more money to get more data. If it's not new, 0.8, how many golf balls in the box are not new? Well, 0.8 or 80% of them, whatever that gives you. Thank you. You're the best. Not new equals 0.8. How many golf balls are new? Here's a fun one. There's a 100% chance of it being a golf ball, and then 0.8 of them are not new. So the rest of them, 0.2 of them, or 20%, have to be new. So whatever point, yeah, like this. Write this probability as a percent. If the probability is 0.75, then that probability is 75%. All right, this is boring. I don't like doing this. I don't think I'll do this again like this. I'll do it at home. What information do you need to know to calculate the probability of picking an onion? It's got peppers, onions, and tomatoes. We just need to know how many there are of the things in the bag. You could even know what percent are onions, and then you would be able to tell the probability. Very cool. What does it mean that you're choosing at random? It means that you pick and everything is equally likely. All equally likely outcomes. That's the important part. Wow, this is so boring. That's why I don't do this. What is the empirical probability that salmonella-caused illness will result in death? Well, we take the number of deaths out of the total illnesses, and whatever you get is the empirical probability. If 100 more cases are reported and they result in one additional death, will the empirical probability increase or decrease? Unfortunately, this means we have to calculate the last one. Let's do it. That's pretty small. How many zeros was that? 375, like that. That's our probability as a decimal. This is not a percent. If you wanted to make it a percent, you would have to move the decimal over twice and put a percent sign on there. If we have 100 more cases, well, then that would be 1.200 cases total, and they result in one additional death. Oh, man, one additional death. Now what? How am I going to find this out? Yes. Good. We had 450 deaths before. Now we have 451 deaths, whatever that calculation is. My guess is it's actually not higher. Let's find out. It's higher? Oh, man. Oops. Well. Like this? Oh, except, yeah, okay, look at you. 0.00375.8. Okay, so it's slightly up. Look at that. If that calculator notation is confusing to you, that E-4 there means that you're going to take that decimal and you're going to move it 4 places to the left. So E-4 means move the decimal 4 places to the left, otherwise divide by 1,000. 10,000. That's good, right? And E+4 would mean move the decimal 3 places to the right, otherwise multiply by 10,000. What a number with 4 zeros. 10,000. This is fun. That was sarcasm. Okay, empirical probability. If the top number increases and the bottom stays the same, does the probability increase or decrease? Let's do a test. Is this a higher probability? Yes, yes it is. So exciting. it goes up. Why? Because now the number's bigger. We have more pieces. Yeah. What do you know about the denominator and the numerator if the probability equals 0? Well, here's a fun fact. You can't divide by 0 mathematically. It's not a number. If you try to do that, you blow up nuclear submarines. Yes, this actually happened. And so you know the denominator can't be 0. That means that the number of possible outcomes has to be 0. So the numerator has to be 0. The denominator we don't know anything about. We just know that the numerator is 0. Okay, that was so much fun.